Solar flights. The important characteristics about considering solar flights is that, first of all, they will be dominated by the sun, and second is the fuel efficiency being the prime concern. For example, let's imagine a trip to Mars. This is the Earth orbit, and this is the Mars orbit. Trip to Mars would take about 260 days. Next, you would have to wait about 460 days for the return trip. And then the trip back to the Earth would take the same amount, about 260 days. So the total is 2.7 years for out and back mission. Incidentally, the radius of the Earth orbit around the Sun defines astronomic unit. Which is about 150 million kilometers. Mars orbit radius is about 1.5 astronomical units. Here are three most important things to know about space flights. First, Hohmann transfer orbits. These transfer orbits occur between two circular orbits. An example is trip to Mars, from circular Earth orbit to circular Mars orbit. Hohmann transfer orbits require two thrusts. First thrust is to move to the transfer orbit, which is shown in blue. Second thrust is to leave the transfer orbit, which would occur at point 2, where you have to give an additional thrust to the spacecraft. Second is Oberth effect, which says use highest velocity of spacecraft to generate most kinetic energy gain from the rocket engine. For example, if the initial kinetic energy of the spacecraft is given by mv squared over 2, and the final kinetic energy is given by new velocity v plus delta v squared times mass over 2, where delta v comes from the rocket engine, then the gain in the kinetic energy will be given as final kinetic energy minus initial kinetic energy, or mass times v times delta v plus half of delta v squared. So you can see that in order to generate the gain, one has to use the engine at the highest velocity. And as we know, the highest velocity of an orbiting object happens at periapsis. Which is the closest point to the object that the craft is orbiting. The final effect that I want to mention is the slingshot effect. Consider a planet moving with velocity u and a spacecraft that comes close to this planet. Initial velocity of the spacecraft is v, so the velocity of the spacecraft after it makes a turn around the planet will be v plus twice the planet velocity. So the slingshot effect allows to pick up planet speed times 2. The greatest example of the slingshot effect is space mission Voyager 1. It used slingshot effect from Jupiter and Saturn to leave the solar system. Here are some of the important dates for the Voyager 1 mission. It was launched in 1977. In 79, it approached Jupiter. In 81, it approached Saturn. In both cases, it gained twice the velocity of those planets. In year 90, it made the famous family portrait, which was a picture of 6 of the main planets of our solar system. And in 2012, Voyager 1 entered interstellar space. Voyager 1 mission would not be possible without the use of slingshot effect.